Okay, so let's just start with the sticker price. $210 for a cable. And, just looking at it, it really looks like any other black cord you might have in a drawer somewhere.
It really does. But I can promise you this is not the cable you grab to charge your phone.
Yeah.
We are doing a deep dive today into the NTI DP8K-FO-30M-MMLC.
That's quite a mouthful.
It is. But the specs are the real story here. This is a 30-meter cable. 30. And it's designed to carry uncompressed 8K video.
Yeah.
And that price, that $200, it's all because it's solving a really fundamental physics problem. It's solving the war between distance and bandwidth.
And that's really the core of our deep dive today, isn't it? We think of cables as these, simple passive pipes. You put data in one end, it comes out the other. But when you're pushing the sheer amount of data for 8K resolution, that whole analogy it breaks down.
Completely. We're talking about 32.4 gigabits per second.
That's a huge number.
It is. And if you try to push that much electrical data through a normal copper wire over 30 meters, that's about 100 feet, physics just says no.
You get signal loss.
You get massive signal loss.
Yeah.
Resistance, degradation. The video would either be a complete mess of static or, more likely, you just get a black screen. Nothing at all.
So on the spec sheet, I see this term hybrid cable. I'm guessing that's the key. That's the workaround.
That's exactly it. Hybrid just means it's using a mix of materials inside. It's got some standard copper wires for the low-speed signals.
Like what kind of signals?
Things like the handshake between your computer and the screen to say, hey, I'm here. But for the heavy lifting, for the actual video data, it's using 4 optical fiber cores.
So it's literally shooting light down the cable instead of electricity.
For the video, yeah. A tiny laser in the connector head converts the electrical signal into pulses of light, sends it down the glass fiber, and then it's converted back on the other end.
And because light doesn't face resistance like electricity does?
You get 0 signal loss, not over 30 meters. The tech can even go up to 100 meters, actually.
Which explains how it can support that full DisplayPort 1.4 standard, that 32.4 gigabits.
That's what gets you 8K at a smooth 60 hertz. Or if you're a gamer, you could do 4K at 120 hertz.
Okay, another term that jumped out at me was active optical. Now, when I hear active, my mind immediately goes to, needing another power brick.
Right, another thing to plug into the wall, a pain point.
Exactly. Does this thing need its own separate power adapter?
And that is the clever part of that hybrid design. No, it doesn't. The copper wires that are in there alongside the fiber, they draw the tiny bit of power needed for those lasers directly from the DisplayPort interface itself.
Oh, that's smart. So it's a much cleaner installation.
Way cleaner. No extra clutter.
But are there other benefits to using light instead of electricity beyond just the distance?
Oh, yeah. The big one is noise immunity, specifically RFI and EMI.
Radio frequency and electromagnetic interference. So basically, stray signals from all your other electronics.
Exactly. A long copper cable acts just like an antenna. It just soaks up all that stray electronic noise. And if you look at who this cable is for, the documentation lists things like medical imaging equipment.
And airplane video systems. I saw that. Those are environments that are just saturated with electronic noise.
Totally. You run a standard copper cable next to an MRI machine, and the signal is gone. It's destroyed.
Yeah.
But fiber is just glass. It's electrically inert. So you could wrap it around a high voltage line, and the data inside wouldn't even blink.
It seems incredibly durable, too. The spec sheet says it operates from -40 up to 158 degrees Fahrenheit.
Which, again, points right back to that aviation use case. Think about an unpressurized cargo hold on an airplane. It gets incredibly cold up there.
I did find one. Let's call it a gotcha in the manual, though. Because
Right.
it has all that active circuitry in the heads, this isn't like a normal cable you can just plug in either way around.
No, absolutely not. That is the #1 user error with these. They are directional.
Right. One end is labeled source and the other is display.
And if you get it backward, you're sending the signal into the receiver, and it goes nowhere.
I can just imagine someone running 30 meters of this through a ceiling conduit.
Only to realize the projector end is back at the computer. It happens.
And speaking of running it, you hear fiber, you think glass, you think fragile. Is this a pain to install?
You know, it's surprisingly the opposite. It's easier than a high-spec copper cable. To get copper to work at these speeds, you need so much shielding it becomes thick and really stiff. This thing is only 5.2 millimeters thick.
That's tiny.
It's ultra lightweight, and it has a bend radius of just 20 millimeters. So you could snake it through a tight home theater setup pretty easily.
It's just so interesting, isn't it? We obsess over the displays, the 8K, the OLEDs, the refresh rates, but we barely give a thought to the invisible infrastructure that has to feed them.
And that infrastructure is really becoming the bottleneck. The simple metal wire is hitting a hard wall, a physical limit. We have to use light.
Which sort of leaves us with this final thought then. If we're already at a point where we need fiber optics and lasers just to connect a monitor across a single room, are we maybe approaching the end of the cable era altogether?
Or maybe just the end of the copper era.
Something for you to think about. Thanks for listening to this deep dive.